We're going to discuss first order linear differential equation. Standard form of first order linear differential equation is dy by dx plus pxy is equal to qx. We can find here the coefficient of dy by dx is 1. And then there is dy by dx and there is y, and coefficient of y is p of x. And the terms without y, they are on the right hand side, that's q of x. We're given any equation, if we can write in this form, then we can solve by the first order linear differential equation. If we are not able to write in this form, then it's not possible to do this one. So to solve the equation in this differential equation, we use integrating factor. So we just define integrating factor. In this method, we need the integrating factor to solve the equation, and we write the integrating factor as mu of x. So our mu of x is defined to be equal to e to power integral p of x dx. So we multiply our equation with the integrate factor, and we'll get here this is equal to mu of x into dy by dx, this is my modified form of my differential equation, plus mu of x p of x into y is equal to mu of x into q of x. Our right hand side, we can write this equal to d by dx of the integrating factor mu of x into y is equal to mu of x into q of x. Now this function of x only, and here we can integrate both the sides. We'll get here mu of x y is equal to integral mu of x q of x dx plus constant c. So I will show you with the help of example that how we apply this method, and we can to find our solution. I have this example. We want to find the general solution of my differential equation given. Now this given differential form, we want to write this in this form, this standard form. So we just divide by dx. I'll get here this equal to 1 plus x square dy over dx. We get here plus, we have plus xy plus x square x cube plus x equal to 0. We just divide by dx. Now the next is that we want to make this coefficient 1, and we are having here the factors. We look on this one. This is dy by dx, and this is y, and this is function of x. So we have to take this function of x on the right hand side. We take in two steps. First I change it to the right hand side. I get here 1 plus x square dy by dx. Then we are having plus xy is equal to minus x cube minus x. Now I divide by 1 upon x square. I get here dy by dx plus x over 1 plus x square into y is equal to take minus x common. I get here 1 plus x square over 1 plus x square. So I simplify this one, the right hand side. I get here dy by dx plus x over 1 plus x square y is equal to minus x. So this is my differential equation, first order linear differential equation. I have written in a standard form, and we can now find our p of x, and we can write our q of x. Our p of x is coefficient of y, p of x is x over 1 plus x square, and my q of x is equal to minus x. Now with p of x, I can just apply my formula to find the integrating factor. I get here my integrating factor. My integrating factor is mu of x is equal to e to power integral x over 1 plus x square into dx. Now I apply the method of the substitution to integrate. I take this equal to z. When I take 1 plus x square equal to z is equal to z. What's my dz? My dz is equal to 2x dx. What I am having here only x, so I have here x over 1 plus x square dx. So I multiply here by 2 and divide here by 2. So I get 1 upon 2 dz over z, and this will give me 1 upon 2 ln of z, and then I substitute the value of ln of z is 1 upon 2 ln of 1 plus x square. I can write here ln of 1 plus x square to power 1 by 2. This is the idea, and we get here the function as e to power ln of 1 plus x square to power 1 by 2, and e and ln are cancelled. We get here 1 plus x square to power 1 by 2, and that is my integrating factor. Now I have my integrating factor. So what's my solution? My solution is d by dx, integrating factor into y, and integrating factor into q of x. So I can write here my solution as my d by dx into integrating factor. This is 1 plus x square to power 1 by 2 into y is equal to the integrating factor into q of x. What's my q of x? Q of x is minus x. So minus x into 1 plus x square to power 1 by 2. So we integrate both the side. I'll get here 1 plus x square, y is equal to integral minus x 1 plus x square power 1 by 2 into dx. I take 1 minus common, I multiply by 2 and divide by 2. I get here 1 plus x square 1 by 2 2x dx. So if I take this as equal to z, my dz is 2x dx. So what I'll get? I'll get here z to power 1 by 2 into dz. What I'll get? I get z to power 3 by 2 over 3 by 2, or I'll write here 2 by 3 into z to power 3 by 2, and put the value of z. I can write this 2 is cancelled with 2. I get here this equal to minus 1 by 2. I get here minus 2 by 3 into 1 plus x square power 3 by 2, and we are having plus constant c 3 by 2, and we have plus constant c. These 2 and 2 are cancelled. We get here 1 plus x square to power 1 by 2. 1 by 2 I'm missing here. This 1 by 2 into y is equal to minus 1 by 3 into 1 plus x square to power 3 by 2 plus constant c. To find the value of y, I divide by this factor. Get here y is equal to minus 1 by 3. I get here 1 plus x square into 1 plus x square 1 by 2. They are cancelled. Then plus c over 1 plus x square to power 1 by 2. And this is my general solution. This is my general solution of the differential equation. I make a quick revision of my steps which I have taken. I have given here the differential equation. I want to solve this one. I write in standard form. This is my standard form, dy by dx. Then coefficient of y, and the values without y will be on the right hand side. So I get here 1 upon x square dy by dx, divide by dx. This is my xy minus x cube minus x. So I divide by this one to make the coefficient 1. So get x over 1 plus x square. Divide by this, we take minus x common, get 1 upon x square. This is 1 upon x square cancelled. So the simplified form, then the equation is in standard form, dy by dx plus x over 1 plus x square y, and this is my p of x, and this is my q of x. So p of x is x over 1 plus x square, q of x minus x. So I find the integrative factor. So integrative factor is my e to the power integral p of x. I put p of x here. To integrate this one, I take this equal to z, and my dz is 2x dx. I get here multiply by 2 and divide by 2. So I get this integral dz upon z is 1 by 2 ln of z. 1 by 2 I take above, we get a ln of 1 plus x squared to 1 by 2. I substitute the value here, the value of the integral. E and ln are cancelled, we get 1 plus x squared 1 by 2, and that's my integrating factor. So I take here this my integrating factor, I got it. I can write my solution as d by dx integrating factor into y is equal to integrating factor into q of x. So I write here, this is my integrating factor into y minus q of x into integrating factor. Integrating this one, we get 1 plus x squared to 1 by 2y, cancel with the integral, dy by dx. And here we integrate, again we are having here the value, we take 2 inside, we get here 2x dx is minus 1, multiply by 2, divide by 2, minus take out, and this is equal to, we just have here, this is my z, this is my dz, and get here z to power 1 by 2 into dz. Integrating this, get z to power 3 by 2 over 3 by 2, 1 by 2 plus 1. And we get here 2 by 3 over z to power 3. Z, the value of z is 1 plus x square, we write it here. Now this 2 is cancelled with this 2, we get minus 1 upon 3, 1 plus x square, 3 by 2 c. No, this is 1 plus x square, 1 by 2 is 1 plus x square, 1 by 2 into 1 plus x square. So 1 by 2 is cancelled with the x 1 plus x square. We get c over 1 plus x square 1 by 2, and this is my general solution. This is how we can apply our method for finding the solution of the first order linear differential equation. We write the exact differential equation for and we solve it. I will give you one more example.